Good morning, everyone. I hope you're well. Welcome to our, I guess every 2 weeks we do this with Dr. Joshua Schiffer at Fred Hutch Research in Seattle. And good morning and happy 2 o'clock on the East Coast. We're going to be talking about, I don't know, COVID-19, the coronavirus. Hopefully we can give you some progress in the science and see what's happening. If you have any questions at all, just please put them in the comments, and I'll try to quickly catch up with them. And like when Pete didn't say, greetings from Argentina to you, Jew Manuel. Here we go. No, I'm not going to request a live. That's not Fred. I'm not going to accept your request to join me. I'm trying to get to Fred Hutch. Thanks on the hair comment. It's reaching new levels. I don't want to, part it, because then I'll look like some sort of, I don't know, like a missionary knocking on your door, which is fine. Hello, Australia. And others still haven't, they'll be on in a second. But Brazil is here to listen, I hope. And Brazil, I hope you're okay. I know you have a lot of cases down there, so we're praying. And I'll show you some steaks soon, Mr. Preacher in Sneakers. If you want to follow a great account, follow Preachers in Sneakers. There we go. Let's add Mr. Hutch, or Dr. Joshua Schiffer. And we're about to go in 3, 2, 1. There he is, everybody. There he is.
Hey.
Dr. Joshua Schiffer, ladies and gentlemen. That's right. Yeah. Thanks for coming. This is our third time?
Fourth time, yeah. Yeah.
I see you. I've seen more of you than definitely my family, but immediate family, you're definitely, our extended family, you might as well be a McHale. You're just going to have to start drinking more and committing crimes.
No problem. More crimes are the same level.
Yeah, the McHale family reunions usually average 3 felons. So, but it's all nonviolent crimes for the most part. This is a whole other Instagram live that we can do later. I'm sorry. How is your rainy weather there up there?
It's great. It's beautiful. Yeah, we've had a run of sunny days, and yeah, it's really helpful for sure. How about you?
Have you paddle boarded?
Yeah, I went out yesterday. Yeah, it was great.
In the rain?
No. It was sunny. It was sunny and nice breeze and beautiful.
Did you fall off at any point did you fall off the paddleboard?
I came very close. I was so tired that I was just tempted to nap out there, and but I didn't. But the water all year round is about 50 degrees. So even incredibly hot days, it's Puget Sound's chilly for sure.
And you're wearing a how many centimeter thick wetsuit?
In the winter, 3, but now nothing. I mean, if you're in it for
just fully naked.
Yeah, there are these men and women who swim in Puget Sound every day of the year with very little on.
Yeah.
And so I feel like I can probably handle it if I fall in I'll cry. I cry when I fall in.
As a doctor, do you recommend swimming in water that cold? Human beings can obviously acclimate to that?
They clearly can. I mean, there are these 2 German women who swim off the point near my house, and they just, it's 20 degrees out and they hop right in. I don't think I could. I think I'd last a few minutes, yeah.
Why does it not surprise me that they're German women?
Yeah, I don't know. And they're always laughing and smiling and having a great time, and they don't look remotely phased when they dive in. I mean, it's extraordinary.
Well, let's get to it now. For those of you that are just that are watching on the live, Doctor, if you could just say what your title is. I know you are a knight. You've been knighted.
Right.
And what you do at Fred Hutch, so people Don't go. Is he in the hair transplants? Is that why your hair looks so good, Joel? But if you could just say, I realized last week I just kind of hop into it without explaining anything. But if you could just say what you do, and then I won't have to say what I do because they know that I tell fart jokes for a living.
Yeah, sure. I'm an associate professor at the Hutch and at the University of Washington, and about 20% of the time I see patients, and I specialize in infectious diseases. And so the majority of the patients we see at the Hutch or at the Seattle Cancer Care Alliance have cancer and also an infection or a risk for infection. So we consult and provide help with that. And my research group is focused on mathematical modeling of infections. And we try to use models to project, first of all, how a person clears an infection when they're infected or not, and why that might be the case. And then we try to use the models to optimize therapies for different things. And so pre-COVID, we had a very strong focus on HIV cure work and also working in human herpes viruses, of which there are 8, 7 of which cause problems with people, and trying to understand how best to treat those. And now we are very focused on COVID and have a particular emphasis on trying to promote early treatment of the infection. But we're really doing a lot of things. Like everybody, we're stretched very thin at the moment.
And that's about your hour. Can you repeat all that? I'm kidding. And I assume your hours are pretty nuts.
Yeah, they're nuts, but they're, because it's at home, there's at least a decent amount of freedom. I think all of us are acclimating to working with Zoom, and I think there's an increasing realization that being on video meetings for 7 hours during the day doesn't help. It's hard, and so there has been a period of acclimation to figure out how to be most efficient, and but we're getting there, and because a lot of the work that my group does is computational. We have not skipped a beat. A lot of my colleagues have had a rough time because their lab work, physical lab work, is physical labor, and so you need bodies there. And the Hutch appropriately implemented physical distancing very early, at about the same time that Amazon did. And so a lot of the labs are not closed down, but running at 20% at the moment. And so a lot of people have adjusted really nicely. They're focusing on other things. They're focusing on finishing up papers and writing grants, but it has been challenging. Whereas our group, we're, 3 times as busy as we were before, which was very busy. And, people are taking on multiple projects rather than a single project. So it really has changed things dramatically. Yeah.
Wow. Did you ever think, I don't know, 6 months ago, that we could ever be in the spot we are now? You knew about influenza back in 1917, 18, and did you ever imagine it could hit this way, the way it has?
Yeah, it's funny because it's sort of, I was quite sure that this would happen in our lifetime, as with many of my colleagues. But that being said, it's easy to say that and think that, but you don't really think it through, I could just sort of rattle off, I think there's going to be a pandemic of some sort, probably influenza. So I was wrong about that. That will force us to close schools for a prolonged period of time and, close workplaces for a prolonged period of time and really challenge the economy. But I never, beyond saying that simple sentence and being a little bit afraid, I never really thought it through.
Right.
It's sort of like living in an earthquake zone when it's coming, but you're not actually projecting what it's going to be like in the 2 weeks after an earthquake. So intellectually, yes.
But was there ever like a colleague of yours? Like, I know there's people here in LA that have bug out bags and have all sorts of prepper stuff for an earthquake. But did you ever have a colleague like that, over drinks, they would just turn to you and go, hey, this coming. And then you're like, there's crazy Doc Brown with his flux capacitor talking about the pandemic. Was there anyone ever like that?
nobody likes to be like that, right? I mean, it's not, you're not much fun at a party if you're an alarmist and you're, so nobody walks around talking like that, but it's always been in the back of our minds. I mean, that in retrospect, I mean, SARS-1 was probably a closer call than I understood at the time. And, it's not as if the world isn't giving us hints that this is a major threat. There's been Zika and Ebola and SARS-CoV-2, and this is all in the last decade. So it's not, I mean, really, at some level, this shouldn't be surprising to anybody. And there's a very I mean, this is obviously terrible. It's obviously a horrible event. There are over 100,000 deaths in the U.S., and I think the number is probably far higher than that because we're undercounting. So it's hard to put a silver lining on this, but there is a worse pandemic out there. There is a pandemic that kills 20-year-olds. And so at some level, we are having a practice run here, and I would like to think that the world will be much more ready the next time than we were this time. And there's even examples of that in the world. I mean, the places that were hit by SARS-CoV-1 have generally done better with this than the rest of the world.
The places that you shimmered a little bit. So the places that had SARS-1, have done better with COVID-19.
Absolutely, yeah. I mean, Hong Kong was clearly ready. Vietnam, to me, is the shining success story in the world. A country that is a rapidly, expanding and growing country and an exciting country, but it's still very poor and has a population density far above that of New York City. And they've really not had a major outbreak at all. They've had dozens upon dozens of introductions into the country, and they've managed to hold things off. And so I do think that experience helps. That it's not the only thing, but it's, certainly you would hope that after this, we would have a much more, just if you think about everything that's gone wrong with the testing, with the really slow ramp up of clinical trials to assess therapies and to treat at the appropriate time, I'd like to think we would get all of these things better the next time. And so everything's a practice run for the next time, no matter how terrible. And so
how did Vietnam knock it down so fast and continue to knock it down so well?
Yeah, they've had, I think the first thing is there's a collective feeling of being on the same team and New Zealand has done this as well, where the leadership has been very open about the fact that this is a shared battle that everyone is involved with, and that we're all in this together, and so that if you get infected, you need to help everyone out and self-isolate. And they've also just been very aggressive. If you were to visit Vietnam now, which you potentially could, you would be quarantined for 2 weeks upon arrival, with testing. And so, and their contact tracing is extremely aggressive and public. If you're infected, I think your name is printed in the newspaper, not as a matter of shame, but as a matter of, hey, do you know this dude? Because if you do, you might have contact with him. And obviously that's a very different cultural paradigm than we have here, but it nevertheless really shows that they have a respect for what can happen, and how destructive something like this can be for the economy and for a country. And so, the U.S. is going to have a different set of solutions. We have a much stronger libertarian streak here than in Asia. But hopefully we would have our own set of tools to, at minimum, very strong testing and contact tracing, but also a much more rapid clip to get to effective treatments than we have now.
And the infrastructure for Hong Kong or for Vietnam or South Korea was set up or the SARS is what what set the whole thing going for them. Going, okay, so this was really bad. Obviously, we didn't get much of SARS here,
Yeah.
but SARS was really bad in Hong Kong. That's where it was.
Yeah, SARS was really bad in Hong Kong. It was the thing I didn't get a sense, I was young when SARS 1 happened, but I've had friends who were in Japan at the time, and I've heard about Vietnam as well. And if you look at their case numbers, it wasn't that high. But at a societal level, they went through something akin to what we're going through now, where there was deep fear, where there was really very implicit social distancing.
Yeah.
So there's a familiarity to all of this that we don't have. And so even in the places that didn't have a lot of cases, and actually Toronto was the other place that really had a very tough time with SARS-CoV-1. And so there's a historical memory about what it was like to go through that is lacking here.
Yeah. All right.
Yeah.
So now that brings me to talk about antibody testing because obviously testing and contact tracing, as you said, is the only way. Like if you go to Korea right now, you're quarantined for 2 weeks before you're let in out into the population. But in Forbes, it said that up to half the antibody tests are false or could be false. And so then I hear that and I go, well, how can we trust any of these tests? Or if we don't, how do we know what's real and what's not real? And there's people walking around there thinking that they've got the antibodies when they very well might not, and vice versa. And so I it's hard to wrap my head around about what do you do? Is that normal for that, or how can you explain how that works, or
Sure.
why it's so far, it's so bad, or the 50% wrong seems like unacceptable?
Right. So let's separate the PCR from the antibody test. So if you were to go to Korea, you would, I'm not 100% sure, but I think you would get a PCR test. And that's what's available when people go to get tested. And as far as tracking whether somebody is infectious, that's the important test because it denotes the fact that they're infected. And so that test also has false negatives. But to me, the false negatives, there's a nuance to them. There's been a number of papers that have showed that the preponderance of false negatives are either very early. So let's say I get exposed, I get a test, it's negative, but that's just because the virus hasn't yet replicated in my nose to a high enough level where you can detect it. And then you check the next day and it's positive. That's a pretty dangerous false negative because if I'm just at the start of infection, I could potentially have a very high viral load. And so that explains the quarantine for 2 weeks, is that even if you were to have a negative test and then you converted positive, you're still quarantined. There's another brand of false negatives that is much less harmful, and that is something I've been talking about a lot, which is at the later tail of infection, as the virus is going away, people shed for weeks and sometimes months at very low levels. And there is not yet any data that these people are infectious. So, and what is also clear is that if you take somebody who was infected with SARS-CoV-2 several weeks ago and you sample them every day, they might be positive at a low level on Tuesday, negative on Wednesday, negative on Thursday, positive on Friday, all at low levels, and all with virus that is not apparently infectious. So they're detecting the RNA, but not virus that it can actually take off and grow in a plate of cells or a culture. Okay. And so the false negative, and then the third reason somebody might be false negative is that the sample isn't adequately done. And I think that's, a real thing, and it's not fun to get these samples. And so, but for the most part, it's very early infection, which is potentially bad, and very late infection, which is probably not so bad. And so that's, as far as infecting other people, that's the test that matters. You mentioned the antibody test, which is different. That's the blood test, which is looking for the fact that your body's plasma cells are producing antibodies against the virus because they've been exposed to it before. And it's pretty complicated. This is really just from reading, the New York Times, because it's such a huge thing, but there were way too many serology tests developed up front, and many of them were not good.
Right.
So if you have a test that is 50%, that's like tossing a coin. So it's worse than nothing, because you're paying money for it and it's not telling you anything.
Right.
But there are tests that appear to be very good. So the Abbott test has been tested by people at the University of Washington.
I'm writing that down.
And what they did was they screened a bunch of blood from people in Washington in the pre-COVID era. So presumably all of that should be negative. And I think there was one or two false positives, if I'm getting this right. It was a very low number, if any. And that is assumed to be cross-reactivity to other coronaviruses. And then they screened a bunch of people who they knew had the virus, and there were very few false negatives. Anecdotally, I'm already hearing from studies that there are people who have infection. A good friend of mine was infected and had an antibody test, and it was negative. So it does happen. That may not be a characteristic of the test. That may be that the person's not producing a lot of antibodies. That's less clear. But here's the subtle thing, is even with a good test, it's not just the test, it's the prevalence in the population. So a positive test so if I were to make a comparison, a positive test in a place that has had virtually no COVID, right? So if you were to screen 100,000 people in Ho Chi Minh City where they haven't had COVID,
mm-hmm.
and you were to get some positives, the likelihood that those would be false positives is quite high. Whereas if you did the same test in a section of New York where there's been very intense infection, the likelihood that they're true positives is much higher. So these tests are not independent of where you're sending them. And that's a characteristic of all serology tests, in infectious diseases and other places. And so they're not perfect tests. And the likelihood of a positive test being a false positive goes up if the level of infection in the place where the test is being done is lower.
Okay.
So it's complicated. In the case of my friend, you can definitely say that it's surprising his test wasn't positive because he did have infection. He had symptoms. Somebody swabbed his nose. There was SARS-CoV-2 there. And then 4 weeks later, he doesn't have an antibody. That's interesting. And either he had the Abbott test, so it either reflects that the test isn't perfect or that he truly doesn't have antibodies that can be detected with the test, one of the two.
He had COVID. And does not have the antibodies.
Right. And
is that common?
So the numbers I have seen have been anywhere from 0 to 5% in different studies. I've also heard anecdotally, though I have no data to prove this, but I've heard from colleagues that there appears to be a relationship between how severe one's infection was and the likelihood of a positive test. So if you get a bunch of people who survived severe COVID, were in an ICU, sick for weeks, and check their antibodies, it looks like they're much more likely to be positive than in people whose infection was quite mild or even asymptomatic.
Okay.
And that's not totally surprising to me, because you can imagine a situation where the immune system gets much more activated against an infection when there's more of it to deal with. And there's data for MERS infection, which is the Middle Eastern respiratory virus infection that has a similar, similar thing where the folks who are less symptomatic were less likely to have an antibody. So then what does that mean? Does it mean that the person who had a mild infection is not at all protected against a second infection? I'd say we don't know. I would hazard a guess that they're probably in better shape than somebody who's not been exposed, but I don't think we know yet.
Is that similar to, does that happen with flu as well? Where you get a light version of flu and somebody else was more exposed, so they get a terrible flu? Or stupidly assumed that once you got either COVID or the flu, once it started reproducing, it just went bananas and had a field day inside of you, whether you got a small viral load or a huge viral load.
Yeah, it's a great question. And it's with flu, we've always thought about it a little differently. With flu, the way that we've thought about this is that there's strain variation and that the virus evolves from year to year. And that I think it's the average person gets flu 2 or 3 times a decade. And that, sometimes it's less severe than other times. But a lot of that has been attributed to whether they've had exposure to a similar flu in the past.
Okay.
This is a little different because for all of us, this is our first exposure. And so there is curiosity about, gosh, if I've had a different coronavirus recently, am I better protected against SARS-CoV-2 than somebody who hasn't? Or even the idea, am I more prone to severe disease? Could the antibodies against one virus potentially be harmful? All of these things are being tossed around. But, in influenza, the one thing that people are, and we've discussed this, that where people are very keyed in on with SARS-CoV-2 is the inoculum dose. Whether if you get a larger exposure, you're at greater risk. And, the same thing should apply to flu, but in the past, I haven't heard flu scientists talk about inoculum as much because they've been much more fixated on this variable strain from year to year.
And when you mean inoculum dose, can you explain that?
Yeah, so the amount of virus that you're exposed to when you get infected. So,
okay.
So it's quite possible that somebody could get infected by a single virus entering a single cell. That's it. So and in fact, it's even possible that the entire worldwide pandemic started with that. Just one virus entering one person's cell in a market in Wuhan. We'll never know, but that's enough to spark an infection. But it's also possible that somebody could get exposed to thousands of viruses, which seed different places, different locations in the lung. And that having that larger exposure predisposes to worse disease. Anecdotally, there's a real concern about that because there's not otherwise a great explanation for why young healthcare workers have gotten very sick with this relative to young people who have been exposed in the community. But it hasn't been formally proven, and to formally prove it is extremely hard. The way you can do it is with an animal model of infection where you control the amount that you give the animal. And I'm sort of hopeful that those experiments get done because it's really useful information. And it also might have some effect on how well a vaccine works, for example. The other way you can do it is if you happen to have exposure information, which is just so hard to get. But for SARS-CoV-1, there was a signal that getting exposed to a larger amount of virus was more harmful.
Okay.
So, yeah.
Then that makes sense. And then I read that I think it was last week, released that the hard droplets aren't as worrisome, or we shouldn't be as worried about hard droplets because catching it off of surfaces when we didn't know anything, I don't know, 6 weeks ago, but I read a thing, they're like, it's unlikely you're going to catch it off of a surface of something, or it's very difficult. And can you talk to that a little bit?
Yeah, I think that's my understanding as well. It's really hard to apply precise numbers to this, but I think the general feeling is that most of the spread is respiratory, and that's the primary way to prevent infection.
Yeah, okay.
by droplets and not by a contact.
I mean, I guess that's one little positive out there.
Yeah,
but I think that also is going to. I hope that doesn't cause people to go, oh, well, we can relax and not. I mean, what do you think of people with everything opening up now? People, I don't know, playing tennis, standing far apart from each other, outdoors where there's circulating air. I'm assuming they're not wearing masks. Um, if you saw something like that, would you be going, well, we're taking a pretty big risk, or would you say it's probably fine?
Yeah, there are two things I'd like to touch on there. The first is coming back to the science. There's an increasing appreciation that the virus is spread not entirely, but that there's a real role of so-called super spreaders.
Okay.
And that term, I think, often initiates the wrong response in people. I think when people hear super spreader, they think of one person who is, shedding the virus at a really high viral load, and that person is somehow special. That's yet to be proven, and I have my doubts about that. What I think is that there is a brief period of time when people are really highly infectious, many or most people, and if they happen to be in a crowd of a lot of people, they can really infect a lot of people with this virus, which is a little bit different than influenza. And the way that some really nice papers from Israel and Hong Kong, and looking actually at global cases, have estimated that 10 to 20% of people are responsible for 80% of the cases. And that, in fact, most people who have infection don't infect anybody. And so the importance of that when thinking about things like playing tennis is that the most risk you could pose as an individual is putting yourself in an indoor environment where you're around a lot of people. And so, when I see two people playing tennis, which I'm seeing a lot of these days, that doesn't really worry me so much. And particularly if they're in the same family or they've both been socially isolated. What worries me, are things like restaurants and gyms,
Right.
airplanes, where the role of a super spreader event is really very real. And the problem with this super spreader event is that it then accelerates the rest of the process, because if you're starting at a number of 50 rather than 2, you have much less time to shut down. And the number of examples across the globe of super spreader events, it started with this Biogen conference, but there was, a guy in Korea who spread it to hundreds of people in clubs recently. There's a factory in Ghana, a fish factory, where there were thousands of infections in a country that otherwise has a very low prevalence. And so I think it's good news and it's bad news, because it really suggests that if you target those places and really limit that type of broad exposure, then you can really have a disproportionate effect on the epidemic. But it does limit certain things that we can do.
Right. I just saw the question come up, but would you feel safe right now going to the dentist?
Yeah. I mean, I think going to the dentist would be on a scale of how urgent the dentist visit is.
Right.
It's funny, like at the beginning of this whole thing, when we were shutting down, I was getting lots and lots of really good questions from friends and family about things like this. And, dentist visits, flights to see ill family members, etc. And that I'm very comfortable talking about the science and the sort of macro level, but at the micro level, these decisions are incredibly difficult for everybody. The key thing to remember is that when weighing these decisions, the truth is right now in Seattle, you could do any of these things and you would be at fairly low risk of infection.
Yeah.
That's the truth. And so, if some restaurant opened here and broke the rules and 60 of us went, the probability that there would be a super spreader event is actually quite low, because the circulating level of infection is low. The problem is that if everybody makes the decision to do this, cumulatively the risk is very high, and then our
Right.
individual risks go up. And so when people ask me things like that about whether I should go to the dentist, what I say, first of all, I try to assess how urgent it is that they would need to go to the dentist. But the second thing is, if it's not urgent, don't think about the impact on your own life. Think about the impact it might have more broadly if everybody decides to go to the dentist, right? And so I think that's where we are, is that when weighing personal decisions, it's not just about yourself, it's about the potential impact if everybody decides to do the thing that you're thinking about doing.
Yeah.
And so, and it's hard. I mean, it's shades of gray. I mean, if I had a terrible toothache, I would definitely go to the dentist. But if I had a routine visit that could wait 2 months, then I would put it off.
Absolutely.
Yeah.
Yeah. I couldn't agree more. And you've seen the opening up of the country, especially last weekend, and it becomes this political hot potato, but I get more, I kind of go, if you're told by the ship's captain to batten down the hatches because the storm's coming, and then the captain says, well, if you want to, it's up to each individual person, each individual room. That's when I go, because like I'm in California, that's done a pretty good job. Arizona is pretty open, but it is 110 degrees there now.
Yeah.
So then you have Wyoming's pretty open, but Wyoming doesn't have a lot of people. And so it's hard for me to it seems like there should be more of a uniform plan here. But I don't know, if you could speak to, are we going to have kind of I start going off into are we going to end up getting herd immunity, whether we like it or not? It just in a way which is kind of sloppy and all over the place. I don't know. I want your opinion on that.
At the moment, the national plan, from my perspective, appears to be no plan. It feels as if we are acknowledging that we're not going to extinguish this and that there's going to be low levels of infection. There has not been a lot of, there hasn't been a lot of openness about how there's a high likelihood that we're going to need to impose strict stay-at-home orders again. If we're not careful, because without social distancing, some degree of social distancing, it will take off. And once it takes off, it will take off rapidly. There's all sorts of strategies that can, increase the amount of social distancing that's permissible. But we can't get back to where we were pre-pandemic without having a surge in cases. There's just too much circulating infection here. And so, it's frustrating. There's no question that we are a little bit stuck, but it would be very helpful to have at the national level some very frank and honest discussion about what the next year or two might look like. And in Washington, I think we've had a better, I think the governor has done a good job of that. I think the way that he's outlined the phases of, the phases of reopening has been good. Perhaps there hasn't been as much openness about the phases of reclosing, if that's where things need to go, particularly in the fall. But it's hard. There's not, and when you see hundreds of people in a pool partying in Missouri and they're not getting arrested, that's incredibly high risk behavior. And so if that sort of thing happens all over the country, there's no way we're going to avoid having another huge spike in infections. And
is there, Dr. Fauci talked about it. He said there is a way to avoid a second wave, but I feel like with how we're going at the rate, I feel like I don't know how, well, first of all, how would we avoid a second wave? I think there will be a second wave.
Yeah.
And you talked about this last last time that you're very worried about a second wave coming when summer's over.
So yeah, I mean, we're developing a math model with some folks at the Hutch who are population modelers, and it's clear that if you were to have a really strong test and trace program in place and a test and isolation program, and even better, if you were to have drugs that allowed post-exposure prophylaxis, not everybody, but a decent number of people had access to those drugs and early treatment, that you could relax physical distancing much more than if you don't have those things.
Right.
But there's no way to get back to zero without widespread implementation of a vaccine.
Right.
And that's just the reality of the situation. But I do think that with all of those things in place and with a pretty adherent population that takes adequate precautions, we could theoretically have a situation where the second waves are really brief spikes that are isolated outbreaks, that might be unfortunately isolated to a particular workplace, but that they're rapidly contained. But it does require all of these things to be in place, and
which we don't really have in place. I mean, there's there's not a uniform at this point. They're just not. Maybe there. I assume in Washington there's open public testing that you can go to. You can just drive to right now. I assume,
right?
But I don't know if that's the case, or it's common around the country at this point, or is it?
I can't speak to state by state, but it does. There is this sort of Hunger Games thing where the states are in it for themselves, which is not ideal.
Yeah,
and I think there's probably great variability. And some of the states that have been spared, which is great, I think are missing the point that being spared puts you at even greater risk because your 99% of your population is still susceptible.
Yeah. And what you just talked about post-exposure drugs, and are those post-exposure the second you have it, or are these drugs that you take after you've recovered, or is it the second that you know you have it, you get them when you get to the hospital, or are they sent to your home?
Yeah. So the idea would be that a physician would be able to rapidly prescribe a drug that has known activity to prevent the spread of the virus to anyone who's had contact with an infected person, and that you would treat that person for a duration of time to prevent them from being infected. You could envision this being done in households, but even better would be in skilled nursing facilities and elder care and assisted living facilities, where actually doing this functionally would not be that hard because you have a known denominator, nobody's going anywhere, and an extremely high-risk population. So the problem is we need to identify the right drug to do this, and that's still a work in progress. But I think that's potentially a great strategy, and it's not new to medicine. We've been doing this with HIV forever. So if I'm working in the hospital and I get a needle stick with somebody who has known HIV infection, ideally I'm on post-exposure prophylaxis within a couple of hours. It's very effective. And so that paradigm makes a lot of sense here and is being tested. For better or worse, the drug that's being tested for post-exposure prophylaxis is hydroxychloroquine.
Right.
Which it's important, to note that just because hydroxychloroquine failed so far as a treatment for people who are quite sick doesn't mean it would fail in this capacity at all. It's a completely different indication. But my perspective is that there is a certain likelihood it would fail, and so it would be great if we were testing other drugs for this as well.
And I just saw the World Health Organization last week. They stopped the hydrochloroquine research, or they stopped the tests that they were doing.
Yeah, they've stopped. They've stopped further research on the drug within this larger study they were doing, but there's still plenty of hydroxychloroquine studies ongoing, both in outpatients and inpatients, that I hope will get sufficient data. There may be a problem that there are two problems, actually. The first is, for that particular drug, there is an issue of bad press,
Right.
and whether you could convince participants to take the drug relative to another drug. The second issue is it's proven very difficult across the globe to enroll people in studies. And this again speaks to our lack of readiness, where by the time you get all of the paperwork done, all of the approvals done, everyone agrees on the study design, everyone agrees on the drug, everyone agrees on the dose. This process is kind of grueling. By the time all of that's in place, the epidemic is on the downslope, and
Right.
so and is infecting people in pockets of society that aren't necessarily easy to access. So, for example, in Yakima now, there's a fairly sizable outbreak, and it's diffuse. It's across the population, but there is a concentration in the fruit growers, and that's not an easy population to enroll in a clinical trial. And there's not really a clinical trial site in Yakima. And so there's been an issue where studies get up and running, not at the peak, but when things are slowing down.
Yeah.
And that's a real challenge that the traditional medical research structure is not designed to tackle. You know, when we talk about treating, if we were to do an influenza treatment study, we would plan a year in advance. And that the whole process, just getting ready, would take forever. And so what would be ideal would be to condense everything that takes 6 months into a week. All of the approvals, all of the study design principles, all without cutting corners, right? All while still maintaining patient safety, while still having a data review board that consisting of people who have real expertise and who can evaluate the safety of a study, all of whom are 3 times busier than they were 3 months ago.
Right.
So it's hard. It's hard
Yeah.
to do this, but that's where we need to be.
Yeah. Ken Jeong and I interviewed for the Darkest Timeline podcast. We interviewed Daniel Day Kim, who was on Lost and Hawaii Five-0, who got COVID.
Yeah.
And he was immediately put on hydrochloroquine by his doctor and a Z-Pack. And he said the symptoms weren't so bad. He said it was still the strangest illness he has ever had to date. That he this typical lost his sense of taste and smell. And he said he felt like he had fiberglass in his throat. And I said, like strep throat? And he's like, no, it was not like strep throat, because he's had strep throat. But he's just very, very different, and all the aches and pains and stuff. But then he said, so he's on the hydroxychloroquine, whatever you said, and then a Z-Pack. And then he said the day that he stopped taking those, because they had run their course, it got so much worse. And then he was back in bed. And that terrified me. And then he has still had trouble focusing, because there's evidence that it can cause like plaque on the brain, perhaps. And he's not sure if he has it, but he still, to this day, since he's been over it for a while, that he has this plaque, he believes, but he really has had trouble focusing. And it's terrifying. I say this anecdotally, but if you could speak to that, and I mean, it was terrifying to hear it, and like a horror story. So that's when I think that when I see people being relaxed and going, it's not a big deal, it makes me shake my head. Like I just listen to anybody who's been through it. Yeah,
I anecdotally have had, I guess, 8 or 9 friends who've had it, and a couple of them have had a really rough time. 6 weeks of prolonged fatigue, in some cases fevers, and just not feeling ready to go back to work. So I think it's a really important message to broadcast to younger folks that, if you get it, you probably won't die. And sure, there's a 30% chance or somewhere in that neighborhood that you won't even know you have it. But there's a decent chance it's going to take you for a really nasty ride. And that's another reason to treat early. We're not just talking about preventing death. We're talking about getting people back on their feet, and the cost to the workplace of having people who are missing work for weeks on end is substantial. It's a huge economic cost. So there's a huge amount of unknown about this. And one of the things we're trying to generate energy for locally and nationally is the idea of a post-COVID clinic, where we're pretty regimented about following people in a way that's standardized so we understand this better. In particularly looking at lung function, there are some people who have had something called an organizing pneumonia, which is a non-infectious pneumonia that progresses once the virus is gone. And that is a known thing. I mean, we've known about this for other infections, but it's something we need to get a feel for. How common is that? How severe is it? Do you need to treat it? And then there's, the other group of doctors who I think are going to be of great help are rheumatologists. Because if the complications that people are having post-infection relate to the immune system being too on fire and too hot, then they have a great deal of experience dealing with this. And again, viral infections often can serve as a trigger for rheumatologic diseases. So that's going to be a real need for our society for years to come, I think, is organized post-COVID care to follow people who are suffering for a longer period of time and understand that better.
What's the percentage of people getting pneumonia after they
I have no idea. I mean, I can tell you it's not high enough that the hospitals are filled with post-COVID complications, but it's not low enough that we're not hearing about it, so it's the type of thing where I'm sure it's going to happen, and that we need to understand it better. I can hazard a guess that it's less than 1%, but it's out there. It's not, and the pediatric story is quite similar. Again, it's not very common, but it's scary and needs to be understood better. This Kawasaki-like syndrome.
Right. And you said last time that there was a genetic component to that, most likely.
I think so. I mean, we don't know. That's my bias going into it, but we'll see. Yeah.
The other thing, when Daniel Day Kim got it, he was with his 17-year-old son in New York, living in the same small apartment, and then they took a flight from New York to Honolulu direct, and they sat right next to each other, and and the kid did not get it. And he was tested for antibodies, did not have the antibodies.
Yeah.
So just didn't get it, and I that shocked me. I would have assumed he would have had the antibodies somehow.
That's part of this super spreader story, is this idea. It's not just that one person can spread to a lot of people. It's this idea that most people don't spread to anybody. And so that is entirely, I've heard that story many times now of people who are stunned they didn't infect family members. What I think is going on there, and this is something our group's working on and trying to model a bit, is that there's a real sensitivity to viral load, and that there's probably a pretty narrow window in which people have a high enough viral load to spread to lots of people. And then there might be a slightly wider window in which they can spread to a few people. But we're not sure. But it is clear that after about 10 or 11 days, in every study that's been looked at, after people develop shedding, that they become much less infectious to the point of 0. So there is this tight window. And so it's possible that by the time they were on the plane, he still.
But you just froze.
But
say that again. Say that again. You just froze.
Oh yeah, my phone rang, which is like unusual. But it's possible that he while on the plane he was still shedding virus, but just not at a high enough level to infect his son or anyone else around him.
Yeah.
Or that he was and they were wearing masks, or I mean, who knows? It's tough to
yeah. That's what is so maddening to me is the unpredictable. Just there's so many question marks and it's hard to I just can't get my head around all these. You go like, oh, okay, well the hard droplets, all right, so that seems to be a thing that's not necessarily a thing.
Yeah.
And I go, okay, that's good news. And then so many people, and you've already talked about it, about reinfection, we just don't know. If you have a light case, maybe you can, maybe you won't. It's just there's still no data on reinfection or a lot of it on reinfection.
Yeah, I've yet to see a definitive case in the literature, which is
Right.
good news, but it's really hard to prove.
Yeah, I mean, the only way you can prove it is through animal testing.
You could do it with animal testing. The other way is if somebody gets infected in March and then they show up to their physician sick in August and you check their virus and they have it, there are two possibilities. The first is that they're sick for some other reason, or they have an inflammatory issue related to their past infection, but it's the same infection. Or they could have been reinfected. And so the way to prove it formally would be you would sequence the first virus. So you would look at its DNA message and, the series of nucleotides, and you look at the second one. And if they're totally different, then that person's been reinfected.
Okay.
And that's hard to do. That requires, a lot of skill at a lot of levels to make that happen. So the fact that we haven't discovered it doesn't mean it's not happening.
And your guess is I'm not obviously, is that reinfection is probably unlikely.
Yeah, I think that I'm not as sure about that. I think that what I would say is that the second infection is likely to be blunted related to the first. That whether people are completely protected remains to be seen. But I would be a little bit surprised to see a situation where people who are really sick the first time get reinfected with the same degree of severity. That could it, and if that happens once or twice, that's not the same thing as saying that it's a common thing. That would really surprise me, and that would really be disheartening. But I'd be surprised if we see that. I would not be surprised if in the fall we start to see definitive reinfection, but that the viral load is lower the second time. The symptoms are not as bad. That I think wouldn't surprise me at all.
That would be a leper. Which brings, I'm going to talk about two more things.
Yeah.
I've kept you for a long time, but I'll quickly, because I keep telling people this as I walk around, because you were very emphatic about it 2 weeks ago, because the good old regular flu is going to be coming here, I don't know, a couple months. Flu shots will start coming out in the summer, and then I guess September is when it really rolls around. And if we got flu going and a second wave, watch out, because that seems like the worst combination I could possibly dream of, next to like an energy drink and vodka.
Right. I just got distracted. I don't ordinarily look at the comments on the bottom, but somebody said, I don't think coronavirus is worse than flu. And they spelled flu F-L-E-U-E. So,
okay.
So let's just go with that.
Yeah. Technically, that sentence is correct for whatever that person is referring to.
But anyway, I should answer your question, but I thought that might be the authoritative answer, that it's not worse than,
worse than F-L-E-W-E-W. Great.
Right. Which is just terrible. But anyway, it'll be interesting what happens with flu, because social distancing would affect flu as well.
Right.
So I sort of feel as if we can have some degree of success maintaining and not.
By the way, the guy just said he was sorry. He's from Germany.
No problem. I can't look at if I look at the comments the whole time, I think I would.
Yeah. Look, someone just invited us to hamburgers, so I think that would be great.
That's great. But yeah, so the two might track together. And flu, we're not terribly good at predicting how bad of a flu year we're going to have in general.
Right.
And so it's really hard to make predictions about that. I worry about stuff, and obviously if we have bad coronavirus and flu circulating at the same time, that's really problematic. But it's not independent from physical distancing. So I would be really surprised if flu took off where in a setting where coronavirus hadn't, because we're doing a good job with social distancing. But we'll see. It's hard to know.
All right. So then, as everyone asks you all the time, where'd you get your glass frames? No. We get just the second phase of that of the vaccine has gone, or in second phase of the one out of Oxford, I believe, the one that switched from doing a MERS or SARS vaccine, switched over to COVID-19, and it looks like Ken Jeong, when we did our 2 weeks ago, or a week ago, it was the first time I'd ever seen him positive, because they had already been doing years of research, and everyone asks, does that mean we'll have it and all that? And I still see it as it's like building a battleship where it just takes forever, because you don't want the thing to sink when you push it out of the dock. And so what do you think of, I think it's the Jenner Oxford one. Am I totally wrong about that? The one that we gave $1 billion to?
So there's so many vaccines being tested that it's not totally easy to comment on the whole thing. That the data that's come out is the Oxford vaccine. They did a study in monkeys, and it was sort of halfway there. It did not protect the monkeys completely, but it protected them from severe disease. So they did not get pneumonia, but they did shed a bit of virus, so that it's worth really thinking about the vaccines. It's not just when we get them, it's how effective they are. And there are lots of beneficial things a vaccine could do. The best thing a vaccine could do would be like a measles vaccine, which completely prevents people from getting infected.
Right.
But, the influenza vaccine that we get every year doesn't do that. Its effectiveness varies from year to year, from very low to 20 to 30% to 80 to 90, depending on the match. And when you get partial protection, that could mean one of two things. It could mean either that, so like, let's say you get 70% protection. That could mean that 70% of people who get the vaccine aren't infected, are completely protected, and 30% aren't.
Mm-hmm.
Or it could mean that 0% of the people who get the vaccine are completely protected, but that everyone who gets it has partial protection, meaning that they get, there's something called a counterfactual, where I get the vaccine and I get a 3-day mild illness with 2 hours of fever and a cough, and I'm better. The counterfactual is that I would have died had I not gotten the vaccine. And there could be something in between, where some people get full protection, some people get partial protection. But, the partial protection is great because they're not sick as long and they're not as likely to transmit. And so when thinking about what the vaccine might provide us for society, we really have to think about all of those things. And it's worth noting that the Oxford vaccine, in the very few monkeys that were given the vaccine, did not provide full protection. And we don't know if full protection is even possible against a coronavirus. And so it really remains to be seen, but it's not as simple. We've talked in the past about all of the issues with scaling up production of vaccines and how that takes forever.
Right.
And a lot of money and time, and usually government investment to help make that happen. But there's also this issue of what to do if we have vaccines that are not perfect but provide some benefit. And then what the business model is if AstraZeneca has one vaccine and Merck has another and Pfizer has another, and they all are better, that some are better at other things. Do you target, for example, the elderly with one vaccine and the young with another? So there's a lot to be learned, and we don't like to talk about this, but there's even the potential for harm in some of these studies.
Right.
And before we have randomized controlled trials in a lot of people, it's really hard to comment on what will happen. I like the fact that the vaccine makers are being bullish. I like the fact that they're making statements that we're going to have, available product in early next year for the most vulnerable. I like the fact that that's the goal, but there's so many things that could go wrong. And more likely, there's so many things that are not necessarily going wrong, but where we get the results and we're like, that's tricky. Is it worth, if we have a vaccine that's 20% effective, is that worth it? How many lives does that save? How do we figure that out? If we have a vaccine that's 100% effective, but 1 in 1,000 people who get it has a severe side effect, is that worth it? And, all of these things are possible and we won't know till we have the data.
Right. And when you see all the bullishness, all the research, and some of the claims, like they'll have it by January or they'll make whatever, do you as a doctor, do you think that's possible?
I do not think it will be possible to have enough of an understanding that you would want to roll out a vaccine to a large number of people before really testing it. To me, within the vaccine context, the big issue is going to be, how do you do the studies in places where there's enough infection to make sure that you see an effect?
Right.
Because if you're giving 3,000 people a vaccine and 3,000 people a placebo, and there's no infections in either group because there's no infections in that community, you don't learn anything.
Yeah.
And so the real interesting story that will develop over the next, I think, 3 months is whether we're going to need to do human challenge studies to understand whether a vaccine works, or whether we can do traditional vaccine studies in the right populations. And, increasingly the populations in our country that are getting infected are poor and disenfranchised, and
right.
The people who need it the most. And I would advocate from the depths of my being as strongly as I can that we need to target these people for studies and for interventions. But they are hard populations to get in studies, and so none of this is easy. And so that's the big picture in the vaccine world. It's hard for me to make a prediction about which particular product will win the race, or whether several products will win the race. That's anybody's guess, I think, at this point.
Okay.
Yeah.
Well, doctor, I've kept you for over an hour.
Yeah.
That means I've kept you for an hour from, doing your job. So I'm responsible. But I'd love to, whenever I talk to you, I feel smarter and dumber. No, but I can't thank you enough. Your straight science is really, really important. And it makes me always like, I've got a little more information, which makes me feel less anxious. So thank you.
Yeah.
And if you want to watch this whole thing back, we're just going to repeat everything we just said. So tune in. No, you can go to my Instagram, or you can go to fredhutch.org/McHale. I am not a doctor, and you definitely would be severely injured if you let me be your doctor, because I would be terrible at prescribing things. So, but that's fredhutch.org/McHale. And and so thank you. I'm sure you have a lot of questions about my movie coming out next Friday called Becky, starring Lulu Wilson and a bunch of other really great actors. Including Kevin James, but we can do those next time. So, doctor, stay healthy, dear God.
You too.
And I guess we'll go to Dick's Burgers with this Matt guy who keeps wanting to get a burger with us. So thank you very much. You want to do this in 2 weeks?
Absolutely. It's so fun, and I feel like it's helping people. So let's keep it going.
Great.
All right.
We'll see you then, and thank you.
All right. Have a great one.
And thanks to everyone who tuned in. Right on, you guys. See you, doctor. Thanks.
Take care.